Hey developers, today we're diving into TypeScript, what it is, why you should care, and how to use it in your projects. Whether you're a beginner or just curious, this video is your launch pad to modern JavaScript development. And I'd really appreciate it if I can have a like and subscribe if you enjoy this content. Right, let's get into it. So, TypeScript is like JavaScript with a safety net. It's developed by Microsoft and adds static typing to JavaScript. That means you define the kind of data your variables should hold, and TypeScript will scream at you if you try to break that rule. It doesn't replace JavaScript, it compiles down to it. You still write .ts files, but what you ship is plain old JavaScript, and we'll have a look at that today in our examples. So first up, let's install TypeScript globally. So head over to your favorite development environment. I'm using VS Code here, and open up the terminal and do npm install -g TypeScript. Cool. And that should have TypeScript installed into your project. Now let's create a new file and just call it index.ts. And ts is stands for TypeScript, so all your TypeScript files will be .ts. Now if we do in the terminal tsc index.ts, that will compile our TypeScript file into JavaScript. Now at the moment, as you can see, we have nothing in our TypeScript file, so we have nothing in our JavaScript file. And one more thing before we write some TypeScript code is tsc-init. And this will create some basic rules and settings for when you compile your TypeScript code. And this can be useful for various different scenarios, so I'd highly recommend reading some of these, but for the purposes of this video, we'll keep these as the default settings. Cool. So let's have a look at some code. So in our index.ts file, we will have a basic number, string, and a boolean. So immediately the difference you can see in TypeScript versus JavaScript is that you can define the type your variables are, which is very important. And if you do not add a type, it will get inferred by the type that it's being set to. And for example, if we have a boolean, we try to set it to a string, it will start giving us an error saying type string is not assignable to type boolean, which is what the main benefit of TypeScript is. It gives you that safety that you're not doing anything wrong depending on the type that your variable or object or function return type is. So let's just go ahead and compile this. And what you can see in the JavaScript is that it is essentially the same, but without the types. So you are writing a little bit extra code. And you might wonder, what is all this effort for? And really the benefit is during production. So during coding, you might have a few fiddly errors here and there of wrong types and things like that, and having to convert types. But that will save you a lot of time in the future for bigger projects, especially in production where it's really hard to debug. So the benefits are in the future, and you're essentially putting in a little bit of extra work in order to avoid any issues in the future. So let's have a look at some arrays. So this is an array, and as you can see, if we compile it to JavaScript, it just gets rid of the type that we assigned to it in TypeScript, but it looks very similar. And if we, for example, do a hash map or a dictionary, you will see, if we compile this, you can see that again, that looks very similar again. And so some of these are your basic types that you'll probably use pretty much every day in your TypeScript. So you've got number for integers and things like that, string, boolean, arrays, and then dictionaries. And there's also for any type, unknown, void, and never. But don't worry about these for now. We might cover these in a future video. If you enjoy this video, then leave a comment below if you want a video with a lot more detail, and I can make a much longer course on this. But for now, this is just a very basic look through. Now, the other thing we'll look at is interfaces. So these are like classes that define a specific thing. So let's go ahead and define an interface. So here we're defining an interface of user, which has properties of name and age, of type string and number. And here we are defining this one user of type user with name and age. If we try and add something else, for example, you'll see we start getting this error and it does not exist in the type user, so you can't add any additional types, which is really useful for when you're developing. So if we compile this, what you'll notice in the JavaScript is actually that the interface isn't defined, you just have a user with name and age. So you kind of lose that information. So you're definitely writing a bit more code. So just to define this property here, you're writing an additional 4 lines of code, but it kind of gives you that safety in the future as you define more and more users in the future. And where this starts to become interesting is in things like when we have a function. So if we have this function here, for example, it uses the name variable from our function. And if we were to use this function, for example, you can see we start getting autocomplete. So it tells me what property is expecting and what its return type is as well, which starts to become very useful as you have larger projects and you're using multiple different libraries, maybe libraries from external providers and things like that. And you really start to see the benefit of being able to see that strongly typed parameters in TypeScript. But also here, if we didn't want to use name from the method signature, then we can use, for example, our user that we had, and then we automatically start getting some of this autocomplete properties from user, which is really, really cool. And if we were to compile this, then you'll see what this looks like. It ignores things like the interface. And it's really cool to make some stuff in TypeScript and then immediately compile it and just see how that starts to look like in plain JavaScript, as that's what essentially your code will get compiled down to when it's done. And just some other things to look at here, which is that you can have union types in TypeScript. So this is where variables have multiple different types. So for example, ID here can be a string or a number. This can be useful, but also a bit confusing. If we were to compile this into JavaScript, you'll see that it just declares ID and then anything is assigned to it. So it's your guess what ID might be. At least this way it's either a string or a number. And also enums, which are created as a readable constant. As you can see here, status enum, and it automatically gives them those values. For example, loading is 0, success is 1, error is 2. And if we were to compile this into JavaScript, this is kind of what we get in the enum. We get this weird function where, depending on what the string value of status is, it gives us a different thing. So enums, we don't even really have an equivalent to enums in JavaScript. So that is one benefit off the bat, is having enums. So that was a very brief look at TypeScript and how it works and some of its basic types and how you can test it locally and see how it compiles. Now, in terms of how TypeScript is used, so most frameworks now support TypeScript out of the box. So for example, React uses TSX. Angular is 100% TypeScript. So if you work with Angular, you are working with TypeScript, and it's probably one of the best ways to create modern web applications. Vue 3 has solid TypeScript support as well, and you'll find better tooling, better suggestions, and way fewer runtime bugs working with TypeScript in those frameworks as well. So TypeScript might feel like extra work at first, but the productivity gains are massive. You'll write cleaner code, spot mistakes early, and work faster in teams, which is really the most important thing. So thank you very much for watching this video. If you found it helpful, drop a like and subscribe, and let me know in the comments if you want part 2 on advanced TypeScript patterns. I'll see you in the next one.